All right, let's look at the three types of discontinuities. All right, so remember that the definition of a continuous function at a point A is the limit of f of x as x approaches A is equal to f of A, right? So remember that the limit always talks about the tendency. So left-hand side is a tendency, and right hand side is the exact value or actual value. So maybe I'll say exact value, right? So if the tendency does not agree with the actual value or exact value, then there will be a discontinuity. Right? So let's look at the three types of discontinuities. There can be a fourth one that could be caused by oscillation, but in this book we're not going to cover it. All right. So number one, jump discontinuity. Right? So you can see that the graph is here, and there's nothing wrong, but at A there's a sudden jump there. Right? So why is this a discontinuity? Right, so let's check this definition. So we have to make sure that the limit exists at A. Does limit exist at A? Right? So you can see that the limit does not exist because if you look at the left-hand limit, which heads toward that point, and if you look at the right limit from the right, right, it points to a different spot. So left-hand limit and the right-hand limit do not agree with each other, which means that both-sided limit, regular limit, cannot exist at x equals a. So you can see that the number one, it fails the number one condition. So I'll just do that. Right? So the jump discontinuity when the left-hand limit and right-hand limit gives you basically different tendencies. Right? The second discontinuity calls the removable. The reason why this is called the removable is that you can actually fix the discontinuity by moving just one point. Right? So the picture like this, if you have a nice and continuous picture, but all of a sudden there's a hole there, and the point is kind of out of place. Right? So this type of discontinuity called the removable, but because what we can do is that we can simply scratch this and put a point back in, then it's back to a continuous function. Right? So that's why this is called removable. Right? But what's wrong with this? Right? So the limit in this case exists perfectly fine. You can see that the limit tendency is the same, so limit exists. So I'm going to check that. Right? And is f of a defined? F of a is right here, so f of a is defined. Right? Then the only problem is the tendency do not agree with that exact value or actual value. So the third condition is violated. So when that happens, it is called the removable discontinuity, right? And the third type is called the infinite discontinuity. This is kind of an obvious one, right? When you have a vertical asymptote, the limit from the either left or right doesn't matter. It goes to either positive infinity, so shoots up to positive infinity, or it could shoot down to negative infinity, right? If this happens, then this is called infinite discontinuity. And which condition is violated? It's actually the first one. When you have an infinite limit and the limit actually does not exist. So we know that the first one is already violated. So this is called the infinite discontinuity. Right, so we have three basic types of discontinuities. First, a jump discontinuity when you have basically a gap. And then the second one is a removable. You have a kind of a hole there, just one hole. You can fix it. That's why it's called removable. And the last one, third one, is an infinite discontinuity when you basically have a vertical asymptote. Right? That's it. I hope that this was clear.